Okay, question 3. So things are now starting to get harder, and this is actually a lot harder, particularly question B. Although question A, they only give 1 mark, I would consider that not very generous. So it says show that this may be written as this. So what's the kind of main difference between this and this? Well, the cos squared x has turned into a sine squared x. So we're going to have to use an identity to turn cos squared x into sine squared x, and we have one of them, and I'll show you it now in a second. So we have 2 cos squared x plus 5 sine x equals 4. Now you might just know that cos squared x is 1 minus sine squared x, but if you don't, it comes from this identity, the Pythagorean identity. Cos squared x plus sine squared x equals 1, and then just by either subtracting cos squared x or sine squared x from 1, you get the other on its own. So cos squared x is equal to 1 minus sine squared x. That's just subtracting sine squared x from both sides. And now instead of cos squared x, I can put this in. So I have 2 times 1 minus sine squared x, because that's cos squared x, plus 5 sine x minus 4. Expand this out, I get 2 minus 2 sine squared x plus 5 sine x equals 4. Depends which way you want to go here. I could subtract the 4 here, and I get negative 2, because 2 minus 4 is negative 2, minus 2 sine squared x plus 5 sine x equals 0, because I've subtracted 4. And then just multiply across by negative 1, or change the signs across, and I get 2 sine squared x plus minus 5 sine x plus 2. I'm going to just move this here so I have all my equals below each other. Plus 2 equals 0. I'm going to write QED because that's what they wanted me to show. So I've shown this. Now, as I said, 1 mark for that I really think is harsh. That's surely that is worth 2 marks. Anyway, he says, hence solve this for x is between 0 and 2 pi. So I'm solving this. 2 cos squared x plus 5 sine x equals 4 for x between 0 and 2 pi. Now he says hence. So hence obviously means instead of doing this, instead of solving this, I'm going to solve this. So I'm going to solve 2 sine squared x minus 5 sine x plus 2 equals 0. So you might, like, it's a common question to just get this and say solve this, but part A kind of sets you up. It shows you the first thing to do, and the first thing to do is change it all into sine. Okay, hopefully guys you can see this is a quadratic, so you could let y equal sine squared x if you want, or, well, let's do that, yeah. I'll say let y, or any variable you want, let y equal sine x. So y is equal to sine x. So now I have 2y squared, any letter except x, I should say. So 2y squared minus 5y plus 2 equals 0. I need to factorize this. To factorize this, I get 2y and y. I get 2 and 1. Both signs have to be the same, and both signs have to be negative because of this. So I have 2y minus 1 times y minus 2 equals 0. 2y minus 1 equals 0, or y equals 2. 2y equals 1. Y equals a half, or, well, it's y equals 2. Now, that means, because we said y is sine x, so I'm just going to draw a line down here. I said y is equal to sine x, so sine x equals a half, or sine x equals 2. This one, hopefully you know, guys, has no solution, because sine x cannot be bigger than 1, so it certainly can't be 2. So now I just have to solve this. So what's the inverse sine inverse sine of a half. This is one of those ones you should know, or you have to know. Inverse sine of a half is pi over 6. In degrees, it would be 30 degrees, but we're not in degrees, we're in radians, so it's pi over 6. Then, you may have your own way to solve these, but I like to use the cast diagram, so I'm just going to draw very quickly. C-A-S-T. Which quadrants, because sine of x is a half, so it's positive, it can be in this quadrant or this quadrant. This is the sine and the all, not here, not here. So it's going to be pi over 6 there, and then this one is pi minus pi over 6, which is 5 pi over 6. So x is equal to pi over 6, comma, 5 pi over 6, and that's it. If this range was bigger, I might have to do more solutions, but it's just between 0 and 2 pi. There's no negative solutions. That is your answer. And if you subbed, if you want to just be sure, sub pi over 6 and 5 pi over 6 into this equation, and you will see that you get 0. Okay, hopefully that makes sense, guys. That is question 3. I'll see you for question 4.